In response to user requests, RMA Incorporated has released XLThrustBearing. My name is Daniel Lubell, the VP of Sales and Customer Support for RMA Incorporated, the creators of the XLRotor family of software. Everyone knows XLRotor for its complete and easy-to-use rotordynamic suite, and XLHydroDyn for advanced hydrodynamic journal bearing analysis, and now we have XLThrustBearing for thrust bearing modeling. Our standard videos are intentionally short, cover a single topic quickly, and silent for playing in the work environment. This video will be longer and higher level to introduce the features and basic usage of XLThrustBearing. Like all XLRotor products, XLThrustBearing is easy to use and based on an intuitive Microsoft Excel interface. It is operated as an additional module added to XLHydroDyn, but it is run as a standalone product as there's no interfacing with the lateral or torsional rotordynamics required. Starting with the release of version 5.8, all users will have access to XLThrustBearing in demo mode. Like the XLRotor demo, you will be able to run all the features. We will start by opening XLThrustBearing. This is done by opening one of the two XLThrustBearing templates found in the templates directory. One template is for SI units, the other for imperial units. If you're not sure where the templates are, you can find them through the More menu of the Help section of the XLRotor ribbon, as seen here. As you can see, there are several useful links in the More menu. When the template is open, in either units, you will see the same layout. We will break this down into sections: thrust bearing properties, operating conditions and lubricant, analysis settings, plot settings, text output, and plot output worksheets. Bearing properties include all the bearing geometry. Some values will be grayed out if they do not apply for the bearing type you have selected. You select the bearing type here. There are three types: fixed pad tapered land, tilting line pivot, tilting point pivot. With each selection, the appropriate entries are grayed out or made accessible. You will also see that the geometry schematic updates to match the bearing type. For the sake of demonstration, I will go select the three types and make small changes to show how the schematic and geometry plot will update. This is the operating conditions section of XLThrustBearing. In this section, we control the bearing load cases. Specifically, we can define the load on the bearing or the clearance, and XLThrustBearing will calculate the result. A convenient toggle allows you to define clearance or load definition, and in the case of defined load, you will enter an initial guess at the operating clearance. The load or clearance cases are entered in this area, where the analysis text output will appear. The shaded cells with black text show where the user may enter data. The sections that do not apply are grayed out. In this case, set for load cases, the clearance column is locked out. XLThrustBearing will run cases until it finds a blank row. There is no practical limit to how many cases you may run. This is where we define the general operating conditions, like boundary conditions. You see here entries for ambient and cavitation pressures. There is also an entry for lubricant supply temperature. Hot oil carryover permits defining the oil temperature into a pad based on how much is from the supply and how much is hot oil from the preceding pad. Values of 0.5 to 0.8 are common. The lubricant properties may be filled in automatically by selecting from the long list of included lubricants. If necessary, the user may select User Defined from the pull-down menu and enter the appropriate values from their own data. The Analysis Settings section permits adjustments of the modeling. There is a section for flags related to the thermal modeling. There's also a section about the finite element meshing and convergence criteria. In most cases, the default settings will work without any problems and the analysis will remain fast and accurate. Graphical output is important for any modern analysis tools. It is essential for conveying information. XLThrustBearing offers many plots as outputs. The flag here allows you to define which variables plotted on the x-axis of the 2D plots, as demonstrated here. After running the analysis with the default of minimum clearance, you can see these plots. Now, selecting Load, the plots now look like this. In all, there are 5 variables to choose from. The GNU plot settings refer to the 3D plots. XLThrustBearing, like XLRotor and XLHydroDyn, offer 3D plots that you can manipulate into any position. This is especially great for seeing values across the pad. For the 4 values listed here, the user may activate the 3D plot feature one at a time, or all of them. A table of the results is built immediately during the analysis and presented in this area. This gives immediate feedback on the key parameters. Below the standard text output is a section with the additional details. This section shows the results of the last load case. Note that the load cases do not need to be listed in any order, so put the load case of greatest interest, most cases probably the nominal speed, as the last line to get these added values where they're most meaningful. There are a total of 12 graphical outputs. They summarize all the analysis points into clear plots. As noted before, the x-axis of these plots is user selectable at any time. The title block of each plot comes directly from the title cells on the analysis worksheet. Let's go through the plots. First, note that with the x-axis selected to be clearance, the first plot is just a one-to-one plot. Similarly, with load selected for the x-axis, the load plot is the one-to-one plot. Note that the x-axis is changed instantly without rerunning the analysis. In order to get the 3D plots, you will need to run the analysis again. So I'm setting the toggles to yes for the pressure plot option. Quickly, the analysis runs and creates the 3D plot with its own worksheet, noted as P. I click on the plot itself, then use the mouse to move the plot around. Left and right and center mouse buttons each have a function. When satisfied, I click outside the plot and respond yes or no to the prompt to keep the new perspective. You may also select other types of 3D plots. A contour line plot works well if you are printing in black and white later. For digital reports or color printing, the 3D contour color plot is fantastic. In addition to selecting different plot types, you can select which load case is displayed on the 3D GNU plots. In this case, we can go through the list and see how the pressure field is changing with each case. Of course, like all other XLRotor products, there is an excellent detailed contextual help, which you can access directly by pressing the Help button here, or going through the ribbon Help section and pressing Help, and it will immediately go to a page about the XLThrustBearing, which details all the functions and inputs.